I am Dr. D.K. Tripathi, an assistant professor of physics under the Department of Basic Science and Humanities. This is the last chapter of nanomaterials. We have discussed in last three chapters of nanomaterials about the nanomaterials reduction, what is the use of reduction of dimensionality. Also we come to know that what are the peculiar properties of nanomaterial. We have discussed the quantum confinement. We come to know that what is quantum tunneling, and we also discussed the quantum wheel as well as quantum wire, so carbon nanotube, and we come to know about the graphene in detail. So today we will discuss the quantum dots, and then we will go to the applications of quantum nanomaterials, because the application of nanomaterial is such overwhelming that we will have to devote a complete lecture over it. So quantum dots, you just recall in the first class I told you about the quantum dots, that these quantum dots are zero dimensional nanomaterials. That means no material, no dimension of it is in the bulk range. All three dimensions are in the nano range, and because of that its name is given zero dimensional. So quantum dots are very small semiconductor particles, merely of some nanometers in size, and their optical and electronic properties are differing from other nanomaterials because of this fact. One also very important thing about this quantum dot is that its properties are dependent over the shape and size both. Whereas we have seen that other nanomaterials uh, are dependent, the properties of them are dependent over the size only. But here size and shape both are determining the properties of the quantum dots. So this is very good thing about that, and different types of, many types of quantum dots are there, and they are emitting different um, specific frequencies of light. That means wavelengths are different, and because of that the color of the light is different. And also we can say that its very good use is that it can be used as the artificial atom. I told you that the dimension of atom is 10 power minus 14 meter, whereas the dimension of quantum dot is 10 power minus 9. So nearer to the quantum, nearer to the dimension of the atom. That is why it is also sometimes abbreviated or termed as the artificial atom. Quantum dots exhibit properties that are intermediate between those of bulk semiconductors and those of discrete molecules. This is very important thing. Its properties are in between the bulk semiconductor and discrete molecules. Their optoelectronic properties changes as the function of both size and shape, I told you. Now larger quantum dots, larger means whose radius are 5 to 6 nanometer or somewhat up to 10 nanometer, emit longer wavelengths. So if wavelength will be longer, then that color will be like orange or red. It will go towards the red. Smaller quantum dots of radius 2 to 3 nanometer or 1 nanometer, they are emitting the light of shorter wavelength like blue or green. Although the specific color and sizes are varying depending on the exact composition of quantum dots because of their high tunable properties. They are having very high tunable abilities, tunabilities. So quantum dots are of wide interest. They are used in transistors, solar cells, LEDs, diode lasers, second harmonic generations, and quantum computing and medical imaging devices. Now they, because of their, because of the dependence of their property on the size and shape, both the quantum dots to be suspended in solution, which leads to the possible uses in inkjet printing and spin coating. So these are the uses of quantum dots. And without wasting time, let us go to the applications of nanomaterials. This is very, very important thing. And because of this, we have learned the whole module. You see, there are nearly 10 to nearly 10 lakhs of papers are published on the nanomaterials. They are so, you can say that this is such a good subject, such an emerging technology that will lead the whole world in the future. So that is why we will have to learn that where the nanomaterials can be used and where it is used. Okay, you see, this is polymer silicate nanocomposite, and that can be used on the fabrics. Over the fabrics, if it will be put, then this can give the signal about the attack of any bacteria or any harmful virus on your body. So you can protect your body with the help of that. So this will act as the sensor. Surface treatments of fabrics with nanoscale additives can help them resist wrinkling, staining, and bacterial growth. Not only that, if the cloths are made with nano materials, then it will be wrinkling free. There will not be staining and bacterial growth will not be there. And some fabrics are made. Now you see, nanoscale nanoscale films on eyeglasses, computer and camera displays, windows and other surfaces can make them water and residue repellent. The water will not stick to that. The residue will not be there. There will not be any dust. It will be free from dust. It will be anti-reflective, self-cleaning, resistant to ultraviolet or infrared light, anti-fog, antimicrobial, scratch resistant, or electrically conductive. Just think what qualities will we add up and how our life will become simpler. And these are used, but the cause is its high price. But development is going on. Let us see what will happen in the future. Nanoscale materials are beginning to enable washable, durable, smart fabrics. The fabric will be smart. You are using the smartphone. This smartphone can tell your location. This smartphone can tell that which message came to you. This smartphone can tell that which mail came to you. All these things. How many footsteps you walked. Everything. What is your temperature? Like that. So these, using the nanoscale materials, smart fabrics which are washable and durable can be made and also made till now. Equipped with flexible nanoscale sensors, many sensors will be there, and as we are using the cloth on our body, so that cloth, sometimes we are sleeping, sometimes we are sitting, sometimes we are sitting in easy posture. So because of that, that cloth should be flexible, and because of that, if a sensor which is equipped to that fabric is not flexible, then it will be broken down. So that cannot be done. Flexible sensors can be used. We have discussed about the graphene. Graphene can be is the flexible layer. So flexible nanoscale sensors and electronics with capabilities of for health monitoring, solar energy capture. If you want to have the capturing of solar energy so that vitamin D can be produced in your body, and solar rays are only the source of that, so that can be captured. And energy harvesting through movement. When you are moving, then you are using that energy. That energy should be converted. So that device can be made with the help of nanoscale materials by using the smart fabrics. Lightweighting of cars. We want that cars should be lightweighted, but it's in earlier days, cars were heavy weight. But later on, with the use of plastics and polymers, its weight becomes less. But if nanomaterials can be used, then cars, trucks, aeroplanes, boats, and spacecraft could lead to the significant fuel saving. If they will be lightweight, then fuel will save. So carbon nanotube seeds, you have just learned about that in the last class. That carbon nanotube seeds are now being produced for use in next generation air vehicles. Okay, so the combination of lightweight and conductivity makes them ideal for applications such as electromagnetic shielding and thermal management. Electromagnetic shielding is very much required in the case of space weather. Those who are just the astronauts who are working in the space, they always require electromagnetic shielding because a very large amount of energetic particles are radiated there, that is coming from the sun, which you used to call as the solar flare or coronal mass ejection. And because of that, the people are those astronauts which are in the space, they are sometimes feeling the memory lessness, as well as they are affected with cancerous tissues, and many things are there. So if electromagnetic shielding can be given with the help of nanomaterials, then this problem will not be seen. Nanoscale additives in polymer composite materials are being used in baseball bats, tennis rackets, bicycles, motorcycles, I told you, helmets, automobile parts, luggage, and power tools housings, making them what? Lightweight at first, as well as stiff, durable, and resilient. Nano bioengineering of enzymes. This is also very required thing. You see, we want to have the nanomedicine, I just told you earlier. So nano bioengineering of enzymes is aiming to enable conversion of cellulose from wood chips. We know that the cell wall are made of cellulose. So, and this cellulose is not digestible by human being. So nano bioengineering of enzymes is aiming to enable conversion of cellulose from wood chips, corn stalks, unfertilized perennial grasses, etc. into ethanol or fuel. So you see, if cellulose can be converted to ethanol or fuel using nano bioengineering, then what will happen? Our fuel crisis will be overcome. So this is also a very important thing. Nano engineered materials in automotive products include high power rechargeable batteries systems. I told you in the first class during the introduction that the batteries which is produced now with the help of nanomaterials that can be charged within 5 minutes, and it will last for at least 5 to 6 days. So nano engineered materials in automotive products include high power rechargeable battery systems in your smartphone that is used, thermoelectric materials for temperature control, tires with lower rolling resistance, high efficiency, low cost sensors, and electronics thin film smart solar panels. Solar panels, what we know that the solar cell, in the solar panel, solar cells are arranged in series as well as parallel combination. And because of that, what happens? Because of this, what happens that the efficiency of cell, what is estimated efficiency of solar cell is that is maximum 20%. But if we use the low cost sensors of electronics made with this so nanomaterials, then smart solar panels will be developed, which whose efficiency will be very much higher than 20%. So this is very, very good thing, and this is experimented. This is under experimentation. Now, nanostructured ceramic coatings exhibit much greater toughness. You see, nanostructured ceramic coatings, these exhibit greater toughness than conventional wear resistant coatings for machine parts. And that is why nanotechnology enabled lubricants and engine oils also significantly reduce wear and tear, which can significantly extend the lifetime of the moving parts in everything from power tools to industrial machinery. Nanoparticles are used increasingly in catalysis to boost chemical reactions. I told you that they are used as the photocatalysts. So nanomaterials are used increasingly. That means their use is going to increase as a catalyst to boost chemical reactions. You know, catalysts are the materials which can boost the chemical reactions or rate of the reaction. So because of that, the quantity of catalytic material which is required, that will becomes less. So in the petroleum refining, this can be used to convert high amount of petrol, or to refine high amount of petrol with less amount of catalyst. Nano engineered materials make superior household products such as degreaser and stain removers, environmental sensors, air purifiers and filters, antibacterial cleansers and specialized paints and sealing products such as self-cleaning house paints that resist dirt and moss. This is also in the falls in the daily use, because we want that there should be material which should be free from from any bacterial infection. So these all can be got with the help of nanomaterials. Nanoscale materials are also being incorporated in a variety of personal care products to improve performance. Titanium dioxide and zinc oxide have been used for years in sunscreen to provide protection from the sun. While you are going outside at that time, if you want that your skin should not have sunburn, then use this titanium dioxide and zinc oxide at the nanoscale. Creams are found that will protect your skin. So nanotechnology has greatly contributed to major advances in computing and electronics, leading to the faster, smaller, and more portable system that can manage and store larger and larger amount of informations. So in the case of electronics, transistors, the basic switches, I told you earlier that transistors are made without use of PN junction, just by using the nanowires. The basic switches that enable all modern computing have got smaller and smaller through nanotechnology. Okay, so smaller and faster as well as better transistors are formed using this nanotechnology. Electronics and IT application, information technology applications. Using magnetic random access memory, MRAM, computers will be able to boot almost instantly. Nowadays, what happens? If we want to boost our computer, we are giving it time, and because of that, it is going to boost. But using this nanomaterial, magnetic random access memory, which is made of nanomaterial, the computer will boost itself almost instantly. At the same instantly, it will be boosted. MRAM is enabled by nanometer scale magnetic tunnel junction and can quickly and effectively save data during a system shutdown or enable resume play feature. Ultra high definition displays and televisions are now being sold that use quantum dots to produce more vibrant colors. Just in this lecture, we have learned that quantum dots can give the different colors at different frequencies on the basis of their size. So scientists in protective clothing hold up IBM's 7 nanometer chip wafer. Sunny College of Nanoscale Science and Engineering Michael Layer left and IBM's Bala Haranand display a wafer comprised of 7 nanometer chips in a NFX clean room in Albany, New York, and that is used in the computers. That will be used in the computers. So there will be miniaturization. Flexible, bendable, foldable, rollable, and stretchable. You see, the device will be, electronic device will be flexible. It will be bendable. You can bend it. The smartphone will be bendable, foldable, rollable, as well as it will be stretchable. In various sectors, if you want any electronics or electronic circuitry, then can be made with the help of nanomaterials. If you want to wear that material which is related to some medical applications or in the aerospace applications, just I told you that the astronauts are always exposed to the high amount of radiation. So if they can wear some jacket or some shield is there, or anywhere in the Internet of Things. If you want some shielding, that can be done with the help, or that can be produced with the help of nanomaterials. So other computing and electronic products include flash memory chips for smartphones and thumb drives, ultra-responsive hearing aids, antimicrobial, antibacterial coatings on keyboards and cell phone casings, conductive inks for printed electronics for RFID smart cards, smart packaging, and flexible displays for e-book readers can be made with the help of nanomaterials. You see, the smartness is there because of miniaturization. Nanoparticles, copper suspensions have been developed as a safer, cheaper, and more reliable alternative to lead-based solder and other hazardous materials commonly used to fuse electronics in the assembly process. Now, medical and healthcare applications. You see, these are carbon nanotube, which is used for treating the cancer. Nanotechnology is already broadening the medical tools, knowledge, and therapies. I told you that nanomaterials are rust-free. They are not suffering from the corrosion. So if surgery tools are made of nanomaterials, it will not have any corrosion, and it will not have any other, you can say that, infection. So it can be used safely. So nanomedicines, the application of nanotechnology in medicine draws on natural scale of biological phenomenon to produce precise solution for disease prevention. Disease should be prevented, it should be diagnosed, and then treatment. You see, commercial applications have adapted gold nanoparticles as probes for the detection of targeted sequences of nucleic acid. Okay, and gold nanoparticles are also being clinically investigated as potential treatments for cancer and other disease. Better imaging and diagnostic tools enabled by nanotechnology are paving. You see, this is carbon nanotube. Enabled by nanotechnology are paving the way for earlier diagnosis. Diagnosis can be done earlier. More individualized treatment. You have seen in some of the tests, it is written that if the range is from here to here, this will happen. Then it is written that it should be matched with other clinical findings. Why? Because they are not sure about that. But if the tools are made with the nanomaterials, then that can certainly tell that what actually the person is affected by. So more individualized treatment options and better therapeutic success rate will be there. Nanotechnology is being studied for both the diagnosis and treatment of atherosclerosis, or the building up of plaque in arteries. If there is plaque, that can be corrected with the help of nanotechnology. In one technique, researchers created a nanoparticle that mimics the body's good cholesterol. We know that HDL, high density lipoprotein, is good cholesterol. So that can be mimicked by the nanoparticle which is invented, which helps to shrink plaque. So plaque will be shrinked with the help of this HDL. If HDL will be higher in amount, that means if good cholesterol will be higher in amount, then the blocking of arteries will be you can say that prevented, or that can be minimized. The design and engineering of advanced solid state nanoparticle materials could allow for the development of novel gene sequencing technologies that enable single molecule detection at low cost and high speed with minimal sample preparation and instrumentation. You see, nanotechnology researchers are working on a number of different therapeutics where a nanoparticle can encapsulate or otherwise help to deliver medication directly to cancer cells. I have shown you in the last class that how in multi-walled carbon nanotubes, the medicine can be, or different material can be put, which will act as the nanomedicine to minimize the risk of damage to healthy tissue. This has the potential to change the way doctors treat cancer. What we know that doctors were treating the cancer with the help of radiation, and in that way process some healthy tissues were also destroyed. But using this the nanotechnology, which is at very small level, only the affected tissue will be treated and other tissues will not have any effect. So toxic effects of chemotherapy can be reduced, or better we can say that that can be overcome later on. Now the energy applications of nanotechnology. You see what happens? Nanotechnology is finding application in traditionally energy sources and is greatly enhancing alternative energy approaches. Okay, so I told you that if solar panels are made with the nanomaterial, its efficiency will be very, very high. And because of that, what will happen? It will give or produce more amount of energy. Rather than that, if electronic equipments are used or made with the help of nanomaterials, then energy can be saved. So nanotechnology is improving the efficiency of fuel production from raw petroleum materials. We have seen that it can be used as the catalyst. So if a small amount of catalyst is required to refine high amount of petrol, then the cost of petrol will become less. It is also enabling reduced fuel consumption in vehicles. How? Because nanomaterials, if can be used, then vehicles will be lighter and they will consume less fuel. So what will happen? It is having the what will happen that it will require less energy. So higher efficiency combustion and decreased friction engine will be produced. Nanotechnology is also being applied to oil and gas extraction. Okay, the use of nanotechnology enabled gas lift valves in offshore areas, or the use of nanoparticles to detect microscopic downwell oil pipeline fractures. If there is any fracture in the pipeline, that can be detected with the help of nanomaterials. Researchers are investigating, this is not done till now, investigating carbon nanotubes, scrubbers, and membranes to separate carbon dioxide from power plant exhaust. And this is truly required. Researchers are developing wires containing carbon nanotubes that will have much lower resistance than the high tension wires, which are used for the electrical grids. Nanotechnology can be incorporated into solar panels to convert sunlight to electricity more efficiently, that I told you. Nanotechnology is already being used to develop many new kinds of batteries that are quicker charging, more efficient, lighter weight, have a high power density, and hold electrical charge longer. So these facilities are there that can hold the charge for longer time. Its density will be high, have a higher power density. Power density will be very high, lighter in weight, and quicker charging. What you want, that all will be found with the help of nanotechnology. So that is used, and the smartphones will come with this nanotechnology used batteries. Carbon nanotubes are used to make windmill blades. Okay, the windmill blades are made with carbon nanotube, and because of that, the blades are longer, stronger, and lighter in weight. And due to that, their efficiency becomes more. They can produce more amount of electricity. In the area of energy harvesting, researchers are developing thin film solar electric panels that can be fitted onto computer cases. On the computer cases, you can fit the solar electric panels. And flexible piezoelectric nanowires woven into clothing. You see, this is very important thing. The nanowires can be woven in the clothing to generate usable energy on the go from the light, on the go from light, friction and or body heat. If your body is giving some heat, with that heat, the solar panel which is installed on your computer, that will take the energy and convert it to the electricity. Or if there is any friction, that friction energy will be used. Or if light is falling over it, it will use. Okay, as you see, I am just using the light in the room to record this lecture, but that light is not converted to some usable form of energy. but that can be used using this nano materials mixed panels. So similarly, various nanoscience based options are being pursued to convert waste heat in computers, automobiles, homes. You see, your computer becomes uh, hot because of continuously giving out the heat. So if that heat can be used to produce electricity again, that will be better. So that option is also think of. Energy efficiency and energy saving products are increasing in number and types of applications. Nanotechnology nanotechnology is enabling more efficient lighting systems, lighter and stronger vehicle chassis materials for the transportation sector. In the transportation sector, what we require some strong or some more strengthy materials, so that can be used, that can be made using the nanotechnology, and nanotechnologists are trying to build up that environmental applications. This we require. As an engineer, you must know that because of the nano engineering, what is going to benefit the society and what is not going to benefit the society, that is always to be known. Because if we are going to new technology, this does not mean that we should harm the environment. So environmental applications of nanomaterials. Nanotechnology could help meet the need for affordable clean drinking water through rapid, low cost detection and treatment of impurities in water. This is very good thing about that water can be treated with the help of nanomaterials. Engineers have developed a thin film membrane with nanopores for energy efficient desalination. This molybdenum disulfide MOS2 membrane filtered 2 to 5 times more water than current conventional filters. So this filter is having high efficiency. Nanoparticles are being developed to clean industrial water pollutants in groundwater through chemical reactions that render the pollutants harmless. Researchers have developed a nano fabric paper towel. You see, paper towel, a fabric which is made with the nanomaterial, woven from teeny wires of potassium manganese. That means nano wires are used to just to weave this nanofiber or paper towel. Nanowires of potassium manganese oxide that can absorb 20 times its weight in oil for cleaning up the application. So where there is oil, that can be cleaned up with the help of paper towel, which is made of nanowires of potassium manganese oxide. Many airplane cabins and other types of air filters are nanotechnologically based filters that allow mechanical filtration, in which the fiber material creates nanoscale pores that trap particles larger than the size of the pores. The filters also may contain charcoal layers that removes odor. So odor will not be there with the use of this nanomaterials. Nanotechnology enabled sensors and solutions are now able to detect and identify chemical or biological agents in the air and soil with much higher sensitivity than ever before. So another sensors have been developed by NASA. A sensor is developed by NASA as a smartphone extension that firefighters can use to monitor air quality around fires. If fire is there and if the firefighters want to know that what is the quality of the air, that smartphone will give the idea because of use of nanomaterials. Nanotechnology offers the promise of developing multifunctional materials that will contribute to building and maintaining lighter, safer, smarter, and more efficient vehicle, aircraft, spacecraft, and ships. The nano-engineered material in automotive products include polymer nanocomposites, structural parts, high power rechargeable battery systems, thermoelectric materials for temperature control, lower rolling resistance tires, high efficiency, low cost sensors and electronics, thin film, smart solar panels, and fuel additives, and improved improved catalytic converters for cleaner exhaust. You know, catalytic converter that converts or that uh, converts the carbon monoxide to carbon dioxide. So extended range. Nano engineering of aluminum, steel, asphalt, concrete, and other cementitious TCS material and their recycled form offers great promise in terms of improving the performance, resiliency, and longevity of highway and transportation infrastructure. So these are the some other uses of, or you can say that environmental uses of nanomaterials. Nanoscale sensors and devices may provide cost-effective continuous monitoring of structural integrity and performance of bridges, that I told you. That if bridges can be made with the help of carbon nanotubes or nanowires, then that will be cost effective, because that will last at least for 1 million years. If you want to form the tunnel, if you want to make the railway tracks or parking structure, that structure, if is made with the help of nanomaterials, although its costs will be very high, but it will have high strength, its strength will be very high, and it will last for a longer time. So nanoscale sensors, communication devices, and other innovations enabled by nanoelectronics can also support an enhanced transportation infrastructure that can communicate with vehicle-based systems. Game-changing benefits from the use of nanotechnology enable lightweight, high-strength materials would apply to almost any transportation vehicle. For example, it has been estimated that reducing the weight of a commercial jet aircraft by 20% could reduce its fuel consumption by as much as 15%. So this is also very, very good thing about the nanomaterials, and thus we have completed the nanomaterials. Now, I hope that you have found a very good idea of nanomaterials, so that you can have your career in this nanotechnology, or better to go to the research work in nanotechnology, because it is the new branch of science and technology where maximum scope is there and you can enter easily there. So these are the references which I have used. So lastly, thank you.